And I'm going to present myself. I'm Sergio Con, product lead for Framework 1, known as ALP before. And, well, basically, all the transactional, new Linux, and the things we're doing about Linux and containers. And with me today, we have FX. Well, you can present yourself.
Yeah, I can. So my real name is François-Xavier War, but I defy anyone to try to pronounce it. So FX, this is how I go. I am product manager for SLEBCI, so the base container images, supply chain security. The reason why we're here today is the future of BCI on which we are working, the container story for Linux.
Yeah. And then we also have Daniel Run here, but he doesn't have a mic, so he's the product manager for SLE Micro. He's been doing this since the beginning of SLE Micro. He's actually very knowledgeable and a very nice guy, so if you want to ask, he's the right person to ask. I'm going to present, but he has the brains, I just have the body. I'm sorry, that was stupid. Anyway, so thank you for coming. What we call SUSE Linux Container Solutions Roadmaps is because we are in the middle of extending our portfolio for containers. So how many of you have been in any of the transactional, any presentation we have been doing during this week? Any of you has been? Okay, a few ones. So you know everything about transactional and anything in middle, and you know how cool it is?
Some people here have seen the demonstration we did at the booth, the technical booth, of transactional updates for those who did not experience it before?
No. Well, we had the booth. Great. That's been the last one. When the booths are closed, it's bad, because I was going to tell you to go to the booth. But let's try to make this short and go there. We're talking about roadmap. So I need to put this there, safe harbor statement. We are actually in the process of updating our roadmaps. We are working really hard to make sure it's aligned with many of the feedback you have given us, partners and others. And you will see changes in this and more expansions into the portfolio. But I wanted to tell you. I think it's important to say that we are going to be talking about the immutable side of things, the container-based Linux. But there's still a plan for everything else. We have SLES 16 in the pipeline, SLES for SAP. So if you don't think this applies to you, choice matters, choice happens, or matters. What is choice? Happens.
Happens.
Choice happens, so you can choose any of the other flavors. The other thing is, of course, a part of this, many of the encasement come from the use of SLE Micro in Edge, in Rancher, and now in the new AI solution. So you will see how this also introduces requirements and changes into our solution. And we've talked, any keynotes today has been talking about SLE Micro. They also talk about application collection. That's the two topics we're going to be talking. But first, I want to tell you a little of why we're doing this. And for those that has been in previous presentation, I will make it shorter. But the idea here is, again, in real life, Kubernetes right now, I think everybody agrees, is the future. Everybody knows Kubernetes is the right way to go, and many of the new applications are basically designed or going around Kubernetes. Observability, CI/CD, there's a lot of things happening in Kubernetes. But we know that one of the things that is also happening is that technologies doesn't change what is already there. We never substitute every technology with a new one. So we understand this portfolio of different technologies that need to co-live, they need to be together. And we have traditional system, and there's applications that need to be in traditional system. I'm thinking databases, even I know there's a group called Data on Kubernetes that says otherwise, but then depending on who you talk, some of them will tell you that databases don't belong there. I have friends that will say otherwise, and they are more intelligent than I am, so I'm not going to say anything about that. But at the end, you have different ways. And every single time you do something, you need to define your application for the architecture that you're using. So one of the things we are working on, one of the things you are saying, is that we are moving into having content for the Kubernetes container world, where you have the application collection for Rancher and everything that is going ahead there, but also you still have a need for RPMs. And even though they are separate, they have different ways of working, actually you need RPMs to create your containers. There's always an installation of an RPM. You need to have that. What is going here is that developers in the container native world are requiring a speed and a way of working that is different than what we have today. They want to have the latest version of everything, instead of having a stable version that you can basically rely on. But that doesn't imply when you go to production, you don't need stability, you don't need support, you don't need something that works. So what we're working is to go to a place where all of that is a way of consumption. You have everything that SUSE provides, we work on that, but you can choose whether you want to deploy a Helm chart or you want to deploy a container. And when you're deploying the container, you actually can choose whether your flavor is going to be orchestrated, it's going to be microservices oriented, or it's going to be like I've heard from some customers, basically getting your application into a container because that's the way your third-party providers are delivering the content, or just because you want to have it integrated in your system in that way. But around all of that, there's a couple of contents, there's a couple of pieces that need to be there. And the first one I want to be talking, and one we are heavily investing in, it's the operating system. So SUSE Linux Enterprise Micro, and you heard today we have just released SUSE Linux Enterprise Micro 6. It's basically an immutable operating system. And for those that didn't know, well, we basically make every change in the operating system a transaction. And because it's part of a transaction, it can be rolled back. And in order to avoid anybody doing changes outside of the transaction system, we make the core of the operating system immutable. You can still run your workloads because not all the operating system is immutable, just /root and etc and some other things. But you cannot install any package there without a transaction. That make it very stable. And the second thing we do is we separate the operating system from the content that is running. On a SLE Micro, it's the perfect solution to run your virtual machines. It includes KVM, libvirt, so you can run your virtual machines, but also is prepared to use containers as the way to deliver application. So while your core is immutable, your application can be in a container and can change as you need to change because they are in container. And that allows us to be very secure and allow us to be very, very, very powerful in many of the features we have. One of them is because the core is really secure and your application can change. We can reduce the downtime, and we have some features to improve that. But also, it allows us to detach the life cycles. So if your application requires a newer version of a library or a dependency, with containers, you can basically have that. So for instance, for the next weeks until we improve that and we change that, and FX will talk more about that, you can run SLS 15 workloads in SLE Micro 6 because SLE BCI today is based on the SLE 15 code base. So you can mix different versions of the operating system. And the other thing, yes, not to forget that, there's one different. And for SLE Micro 6, we have included the real-time kernel inside the operating system. So in previous version of SLE Micro or SLS, you have an extension for the real-time kernel. In SLE Micro 6, no?
Real-time kernel was always included in Micro.
Okay.
Only an extension of SLS.
Okay, it was an extension of SLS. It has always been included. I told you he's the brains. I'm not. So SLS has an extension for real-time kernel. SLE Micro includes the real-time kernel. So if your application can be containerized and you need a real-time kernel, SLE Micro it's a very good solution to work with that. One of the things of this that is also important is that it has been designed together with our teams from ECM and Edge. And whenever you install Kubernetes, Rancher in the latest version used a slightly modified version of SLE Micro. In the new version of Rancher, you will be using SLE Micro as it is here. So every time you will install the new version of Rancher with the host operating system, you will be using a version of SLE Micro. You just basically can go from a single host OS to part of a cluster installing K3s or AK2. They have been announced to be supported today. But this is not everything. SLE Micro can be used in any place, not only in the data center, not only as part of Edge, but SLE Micro itself can be used in the cloud or can be used in the data center. Until now, that was a possibility that's always been there. But if you have heard before about SLE Micro, I'm pretty sure you have been you've been told or you've been told that SLE Micro was more an edge operating system. One of the things we have realized is that it has its place in the data center, it has to place in the cloud for many of the good things and the features that are included with the system.
There's a question.
There's a question.
Do you have a recommended setup for the file systems in SLE Micro in SLES? It was Btrfs for /root and XFS for data. Is it the same for SLE Micro?
Do you want to answer?
So actually, there's no choice for the file system on the operating system level. So Btrfs is a hard requirement for SLE Micro. For data, you can use either X4 or XFS. It depends on your use case. Both show some different performance depending on a lot of small files or a lot of large files, and either X4 or XFS is adequate. I would suggest XFS for that, and I think the container guys will say use X4. So.
Okay, the only thing is the root file system need to be Btrfs because the transactional updates use copying right on Btrfs. So that's the only requisite. And we have another question.
Two slides before about the life cycle. Can I imagine like be a rolling release distro, the SLE Micro, or would there be fixed releases that you have to update to?
So we keep in the same life cycle in SLE Micro. So we have a release. It's not a rolling release. We have minor releases. The way it is working right now. And it's in SLE Micro 5, and correct me if I'm wrong. We have a version in SLE Micro 5 that is aligned with SLES 15. We release one every 6 months, and that version is maintained for 4 years. So every minor version is maintained for years. We are thinking on extending the life cycle, so if you need more time, we will be happy to talk about that. It's not available today because we haven't had anybody requiring that. Perhaps because your containers can maintain an old version while your operating system is updated. There's no relationship between one and the other. We are keeping the same life cycle in SLES right now, so you will have a version every 6 months, and we will maintain that version for 4 years. The main difference is that SLE Micro 5 was based on the SLE 15 code base. So SLE 15 code base, from that we generated SLES 15, and from that the different operating system were just basically modifications on top of SLES 15. What we have changed now is that we are releasing a new code base and a new way of building things Some of them he will tell you later because we want to be more flexible. And that means we no longer make a SLE micro as a subset of SLES 15. We are making a SLE micro its own operating system going directly from the code base of Framework 1. That is how we call SLE 16. It's Framework 1 because we want to differentiate really what we were doing in the past and what we're doing now. Is that accurate?
Yes.
Okay. Okay, I feel useful. Good. Two things important, and we're working, and you will see more things happening around that. SLE Micro 6 is prepared for confidential compute. Right now, it can be a guest virtual machine in a confidential compute node. So you need to have an operating system that runs in a confidential compute environment. You can use SLE Micro. In I don't know if 6.1, 6.2, we will include the capabilities required to use SLE Micro as a hypervisor for confidential compute. And for those that doesn't know what is confidential compute, you basically, when you run an application in Amazon, the hypervisor sees a process, so it has complete access to the VMs. If you don't want that to happen, what you can do is run in a confidential compute. Confidential compute is a node include an additional chip, and that chip encrypts the memory in flight. So even the hypervisor cannot read the memory because it's encrypted in the hardware. So we support that. So you're running your application in Amazon, but it's confidential. Not even the hypervisor can access your data. Just think of anything secure, your customer data. You don't want anybody to know what you're doing, or you're training your AI data. You don't want to put all that data through a third party. You can use confidential compute for that. And the other part that is required, of course, is when the data is not in transit. When the data is not being used, the data is in transit or is stored, you also need to encrypt it. And SLE Micro allows you to have full disencryption and allows you to communicate using encrypted communication too, so you can have an end-to-end system with encrypted data at all levels. Okay, and we have all the capabilities for these kind of things, like, well, it allows a hypervisor, and SLE Micro by default allows you to integrate with LDAP and other authentication systems. So if you wanna integrate it into your company authentication system, SLE Micro is out of the box prepared to do so. So one of the things you will see, and we are still working, we are focusing more in use cases. So at the end, we had one use case, that was the operating system, and everything came to that. Where we started is to move things. So there's some things we have changed. For SAP, you still have SLES and SLES for SAP, so you can use both. You can install your SAP workloads in SLES, or you can use them in SLES for SAP. And SLES for SAP has some additional capabilities for SAP, like Trento and HA. But at the end, you can use it. For the virtualization host, we are working on that. We thought it will be our preferred operating system was going to be SLE Micro. I've heard lately that we are analyzing this information, and it's quite possible that SLES for SAP and SLES includes a hypervisor too. But right now, what we are thinking is if you need to run your VMs, you can use a hypervisor like SLE Micro and run your VMs on top. We don't find any customer, and if you are one of them, please let us know, that is actually running workloads and VMs in the same node. So it's either a hypervisor host or the other. This allows us to be more efficient because our kernel can be optimized. We don't need to have as many packages and as many use cases. So we can be leaner and faster in giving you support if we do that. We also expanding the concept of BCI. So any of you are using BCI today? Do you know what it is? No? So we offer less content as applications containerized with the same level of support, level 3 support. So if you are running as less host or a SLE micro, you can basically run your MariaDB, your Postgres, or your Nginx in a container using SUSE image and get all of that. Again, FX will tell you more about that. But we're expanding on that concept, and the half of the presentation today is going to be about that. And then there's changes in the technologies that is important for you, at least if you are using them. The first one is we are dropping support for Wicked in Framework 1. So everything is going to be Network Manager for that. We do understand that that means some of your scripts can need some work and some love, but its Network Manager has some capabilities that Wicked was basically not able to provide and has been integrated with Kubernetes and other systems. So we think it's a good solution for everybody to go to Network Manager. The other thing is we are dropping support for Xen. So if our virtualization stack is going to be basically KVM and Libvirt to integrate. So you will, if you are using Xen, that I don't know anybody, I know some partners that are actually heavy on Xen, but customers, I don't know a lot, or any. We are going to move to KVM. Do you have a question? Sorry, I thought you were raising your hand. And then the other thing is the security framework is going to be SE Linux. That if you have used it, has its challenges, but one of the things that is good for that is by default it denies any access. So we are dropping support for AppArmor, and we are just basically adding. So SLE Micro and all the flavors of Framework 1, including SLS 16 and SLS for SAP 16, will be based on SE Linux, and they will include the policies required to use that in production. And so that's what I wanted to say about SLE Micro 6. Again, if you want to try it, please try it, give us feedback. We're heavily invested in the user experience of using a single host for container host in production. So if you find it hard or you need some improvements, send us an email. We will be very, very happy to hear you out and understand what is your use case and try to find a solution for that. And with that,
thank you.
We talk about the content. That is the important thing.
Who here use containers? Where do you get them from? Do you get them from SUSE BCI? So that you need to learn about BCI then. So BCI are our base container images. The idea we had behind BCI is we wanted to provide the same capabilities, the same security postures, the same level of support to the containerized experience that we have on SLES. Basically, that's how we thought it in the beginning. So when you use BCI, base container images from SLES, you have the strong security and compliance that we provide in the SUSE Linux experience. So you inherit from our security and compliance posture for Linux. You have security hardened and FIPS-enabled content. You have all the SBOM you need, and you know you need it, and you know you're going to need it even more with your upcoming regulations. We can claim we have SALSA level 3 grade builds. I don't know if you're familiar with SALSA. It's supply chain level for software artifacts. It's a framework that has been designed by Google in the first place. And the first version 0.1, had 4 levels. And of course we reached level 4, and we were the only one. And at some point, Google decided to release version 1 with 3 levels. So we're still at the highest level there is. And of course, it compounds secure base for any containerized workload. So if you want to consume containerized workload, of course, BCI is a great place to start. You have the base images, you have a development environment for Python, Java, whatever. And you have application containerized as well. And you have 0 to close to 0 CVE, which is very, very very strong differentiator. If you look, I should have picked this slide. I have a slide that I've updated this morning. I showed it to another. We had another talk on supply chain security and containers at noon. And I just picked one MariaDB container from Artifact Hub. The first one you get when you search MariaDB on Artifact Hub, you pick the first one. And Artifact Hub, you have a CVE scanning automated every day. And you can deactivate it if you put containers on Artifact Hub because you don't want it to show bad results. But the first answer you get by typing MariaDB and Artifact Hub, and it's an enterprise level offering for containers, had 110 CVE for MariaDB only. Ours, of course, at 0. So this is really something to keep in mind when you consume containers. It's not just the binary. There is an ocean of packages included that can bear CVE, that can bear liability issues. So that's where BCI really shines. Oh, sorry. It's purpose-built for container native, but that's what you would expect from any container. So it's compatible with Kubernetes distribution. It can use it on, of course, on-prem, on cloud, hybrid cloud, edge, you name it. It's the base on which we build all the containers we ship. So if you download something from the Rancher application collection, it's built on BCI. It integrates super well with Rancher, of course. And as any container, that's the purpose. It's really flexible for software development. You run it on any Linux. It's lightweight. It's easy to adopt. And you don't have to care about configuration. You just pick the components you need. It's really simplified. You know what it is, containers. But all that is great, but we still think there are challenges in consuming containers for our customers. Let's put ourselves in the shoe of the developer. If you're a developer, back in the days, you wanted a component, an open source component that you need. It could be a language stack, it could be a runtime, it could be an Nginx server, for example. You would do zipper install. And incidentally, you would download it from your operating system provider. Because behind zipper install, that's SUSE. And therefore, you have bits with all the security, compliance, everything that is aligned with your operating system. And if you have a subscription with your OS vendor, you also get the support with that. You also get the liability with that. But now, containers, they are great. They're really enabled to empower the developers. But then the developers can find the content they need in other places. And if you have 10 teams of developers and they all go on Docker Hub, Artifact Hub, you name it, and they download the first container they find, you're going to find 10 different providers, 10 different level of quality, 10 different security posters, and it results in blind spots. You don't know if you have a correct alignment between all the containers in terms of supply chain security, supportability and production, certification, you name it. So we think that our customers are in search for a way to help them align the whole organization and best practices. That's one thing where we want to help. Enterprise lifecycle and supportability, it's another one. In a way, when you were consuming open source component by doing zipper install, the OS vendor was driving the open source component you were consuming. And we are very much aligned with the interest of the production. So we are very much aligned with the need for supportability. So you would have supportability for those containers. Now, if we empower a developer to use the container they want, they may not care that much about supportability. And the providers of containers as well. Because this is not the focus when you're a developer. You want the latest, you want the fastest content, you want something that is convenient, and that's totally normal. It's part of the DevOps movement, reduce friction, developer are empowered. But then you end up with a landscape of content that is not homogeneous in terms of supportability. It can be limited to a vertically aligned stack. You can have multiple providers that have different meaning behind what support means. And different SLAs and different guarantee and different way to handle things. So this is in a way a decline compared to the service offering you had by consuming directly from your operating system vendor. And the last one, and I think it's probably the most important one, the risk avoidance. You may be aware about the regulations that are coming regarding supply chain security. Who here is aware of Cyber Resilience Act, Product Liability Directive, Network Infrastructure Security Directive? Yeah, you. Secure Software Development Framework in US, the Memorandum of Understanding 2218, DORA, many regulations that are pending both in Europe and in US. And in many other radiographic, that are now clarifying the liability in terms of software supply chain security. And basically, if you run IT or if you ship solutions, you may end up being liable for the whole stack. Thing is, containers are great, but they hide the stack. You don't know what is the OpenSSL version you have in your container. You don't know what is the libc version you have in your container. But you're going to be liable for those anyway. So you want to work with a supplier that can bear this liability, to which you can offload this liability on the software supply chain quality. And you know that on that, we're the best. We're the only general purpose operating system provider that have reached level 4 augmented of common criteria framework, which is the only framework that is recognized widely through the common criteria framework that encompasses software supply chain security. So if you want to be sure that you do not have any risk in terms of liability for the software supply chain of the container you consume and you ship and you run, you better use containers from a company that can claim this level of guarantee on the software supply chain. And we're the only one around. So that's something important. So we think those are 3 problems to which we can help our customers even more. And we have started to consider what are the use cases where we could improve our position. First one is what we call the responsible container native developer. So we talk about container native developer, so you build containers, but they want enterprise-grade supportable containers for what they do. Why? Because at some point, they want their stuff to end up in production, and they don't want to have a no-go because it does not comply with the regulation, it doesn't comply with the level of requirements in terms of security, it has too much CVE, or the update process is not guaranteed. So if you're a developer, and you work in a company that may have this kind of requirements, you may want to have a solution to develop. You may want to find base image containers and development containers, and maybe even application containers from a reliable source. We wanted to address this use case. The container native platform engineer is the second use case that we want to address. Platform engineer, names are changing every day, but what we imply by that is the organization that is between operation and development. They need to tool their developers with the things they need so that they can develop things faster and comfortably, while still ensuring that it can go to production without creating any problem. For this population, we want to provide enterprise-grade supportable containers for base image, development environment, and application with no vendor lock-in. We want to enable platform engineers to say, hey, we have all this set of containers, you can use it, all the development teams can use it in the organization, and it doesn't matter if it's going to end up on Kubernetes, on Podman, on a Ubuntu, or Rail, or whatever. It's no vendor lock-in, and it can be supported, of course. And then the third use case we wanted to expand to is the responsible ISV, or Edge, or OEM. Basically, somebody that want to ship containers, and that don't want to bear any unidentified liabilities. I want to be able to build a support offering that encompasses the container, the base image, the content that I underneath. And of course, no vendor lock-in, because we are the open source company, and sure it happens. So what we have come up with based on this use case we want to enable, we want to have workload support on SLE and non-SLE hosts. And of course, there will be some limitations, because if you don't control the container environment, you cannot do the full support experience that we can do if we are providing the container runtime environment, but we can still support workload on SLE and non-SLE hosts. Latest content available for free. This is how we can feed all the developers around with what they need to start working. Lifecycle close to upstream. So we want to be able to provide the latest version of everything in a matter of maximum weeks after major release from upstream. And you know how it goes in the world of operating system vendors. We tend to move slower than that. But we want to move faster because we think that developers want that. And of course, we want to have adaptive business offering for all use cases. It's not just about subscription. You don't ask subscription for the host OS if you want to feed the developers, and you don't ask edge vendors that want to deploy containers on millions of devices that he has a subscription for each device. We want also to build the right business offering that makes sense for all those use cases. And how do we do that? Well, if you think, oh, there is one image that I guess it's a, yeah, my bad, sorry, I didn't remove the animation. So if you look on the left, this is how we are doing it currently. So we first start with SUSE Linux Enterprise. You all know SUSE Linux Enterprise, thousands of packages, tens of thousands actually. And our value proposition for SUSE Linux Enterprise is that all those packages are co-installable, meaning you can install all of them in the same system. They will not step on each other's toes. They will be compatible. They rely on the same dependency. The dependency tree, which is complex, it's compatible. It's a lot of effort, but it's a lot of value for our customers because it means we can build a general purpose operating system. With SLES, you can address so many use cases. And also because we have this approach to have releases for the operating system. We have the same life cycle for everything in the operating system. Same life cycle aligned with OS release. This is how we are doing SLES, and this is how we are doing SLE-BCI, because BCI is made out of SLES. So this is all great, but it does not work with what we want to do. As you remember, we want to deliver content faster, closer to upstream. And we cannot achieve that with 10,000 of packages, and it could be co-installable at each moment. So what we're doing, we're leveraging the isolation capability of containers. And now we say, yes, we're going to have base images that is robust, built on a strong, robust code base with a lot of things that are co-installable, because base images are meant to be extended with RPMs. So this is still the same. The base images, so the pure base images you're going to download is still going to be built on SLES so that you can extend it with the RPM we provide and still benefit from the support from the ground up. But for application and development containers, we don't want to carry the burden of having everything co-installable. So we are going to use the framework one, that's hard, approach, so that we can have different separated dependency tree and therefore separated life cycles for every content. And we can get closer to upstream, addressing the requirements of developer and operations at the same time. So just a little bit, a little focus on the workload support lifecycle. I think it's quite important to really understand that. Let's take an example project, upstream project, whichever. You can imagine Nginx, MariaDB, whatever. As you see, we have the upstream project that have releases, V1, V2, V3, V4, V5. That's the life of an upstream project, an open source project. We do not control it, we influence it because we are contributing to maintenance of many open source projects, but we're not controlling it. What we control is the life cycle of our SUSE Linux distribution. So SLES, we have SP5, SP6, and what we do is that when we release a version, we take the latest version in upstream, and we align the life cycle of this version with the life cycle of our Linux distribution. So here you see, we release SP5, the latest version is V1 for this project. So we have support for the V1 version of this project that is as long as SP5. That's quite logical. And then when SP6 release, the latest version that is available is V3, so we provide V3 and we support it as long as SP6. So you don't get V2, you don't get V4, you don't get V5, and you have to wait the release of SP6 to get the V3, which is released before. So that's how we do it currently. But with Framework 1, and specifically with the BCI container, the future of our containers, which we probably call SUSE Application Collection for Linux. So with Framework 1, what we do is we build the lifecycle based on the upstream release. So basically, you have still the same lifecycle for the same component, V1, V2, V3, V4, V5, and we try to provide each version. For this example, we decided that there is one version that we will skip, so we skip the V3. That's our decision. It will happen sometimes. We try to avoid that as much as possible, but we wanted to tell you that sometimes we will have to make this kind of decision. But we try to provide as much version as possible. We try to provide very close to their release date, as you see, like in a matter of weeks, worst case, I think 1 month for very major upgrades, but try to stay very close for major updates. And of course, minor updates, it's a matter of hours after it's released. And we're still going to provide long-term support for a selected number of versions. So here you see the V1 is going to be long-term supported, and the V5 as well. And amongst the principle we want to follow, we try to ensure that there is always one stable version available when we have long-term support. One long-term is always available. And that the intermediary version, there is always an overlap to enable our customers, to enable your developers, for example, if they really need the V2 and they cannot stick with V1, well, they can still have this overlap period where they can migrate to the next version. So nobody is going to be hit with the end of life before the next release is available. So enabling life cycles that are closer to upstream while maintaining LTS option so that we can serve both developers, which usually want the latest version, very close to upstream, but also operation because they want battle-proof solutions with long-term support and the kind of commitment we can take. And everything, of course, enterprise grade with the SBOM, the SALSA, with our liability, with all the certifications. We're going to focus on trying to certify that. There is no certification framework yet for containers, but we're going to focus on working with BSI to get that done at some point. So really still very much committed to having the best security posture, the best liability posture, the best certifications. We're going to have FIPS content, of course, but now trying to follow upstream closer so that we can address developer needs with less friction, in align with the mindset of DevOps and DevSecOps practices, where we want to reduce those frictions. And to conclude, I think it's more on you.
Okay, thank you. It's better if I switch it on. Hello? Okay.
That was intended. I wanted to trick him.
Now it's working. Okay, so why are we doing this? And we're basically complementing, making sure that the portfolio for Linux is way better than it was before. So we used to have a very generic OS, SLS, Liberty, and different versions of SLS, but it was generic. So it has all the pieces, and it's basically up for everything. But actually, we discovered that was not enough, and we created a version specific for SAP that was really, really good at doing things SAP requires to be stable, and that's why we are so popular among SAP customers on the deployment of their applications, because it's really something specific. And then, because we were talking about containers and everything else, we decided to do a very specific OS for the edge use case and for Rancher and for places where it's embedded. So we built an embedded OS. What we have discovered is that actually that model is not only good for the embedded use case, but it's good for every use case. So if you want a system that self-heals, that self-updates, that is always running, where you can update it really quickly because you have new images, it never breaks because it can roll back. If any of the dates break the system, you can roll back. If your configuration, somebody changed the configuration, it breaks, it is still roll back. And using container, you can actually have more than one version of your application in the same host and use one or another depending on which one is working better. Because all of that is a value in itself, specifically when you're going to the cloud and you want to run your application in the cloud, but you don't really want to be checking every few minutes if somebody attacked you. And if you have tried to open a VM in Amazon without an enterprise environment, just go there, open an account, and open a VM. I think it takes like 15 to 20 minutes to see the first attack. There's basically are people checking the IPs, and the moment you have a VM, they will go after you. You want to be sure that you have the latest patches, that is working, that is secure and integrated with everything. Having something like an integrated system, transactional system, immutable system, it's really a value proposition, very strong. So what we're doing is expanding the use of SLE Micro to every single use case. And of course, you don't run operating system, we know that, you run applications. And when you run your application on a third-party application, you really need to have your libraries, your dependencies working. And that's why we've been talking so much about application collection for Linux or SLE BCI, because we see that as a key component of how to move forward. And when you have SLE Micro in the cloud using SLE BCI and the new versions of SLE BCI, you will be basically having all the components needed with the life cycle that you need to run your application securely, updated, and with all the trust that SUSE can provide you in the operating system, but also in the container market. And I think with that, that's the last slide. You have the
clicky. Oh, sorry.
No, you're going
Bad.
back. Okay, let's start again. Who wants to listen to this again? Thank you very much.
Thank you.